are we going to do in this video, Brain?
The same thing we do in every video, Becky. Try and take over the world. With science!
Hello everyone, my name's Rebecca and I'm a neuroscientist here to talk to you today about all things neuro and science. And in this video I'd like to answer another one of the most common questions I get asked as a neuroscientist, mostly by my Uncle Alan. So, is colour really real? In my recent video on whether a computer can ever make a brain, I mentioned that we actually started off trying to make computers that could perceive the world around them, thinking that this would be the simplest problem to start with. It was not. Identifying shapes and forms is actually very tricky, but the side of vision that has always been most interesting to me is colour perception. And everyone happily joined me in this fascination when in 2015, a particularly ambiguous item of clothing hit the internet. #TheDress was an overnight sensation, with millions weighing in on whether they thought the dress was white and gold or blue and black. I have started wars in classrooms over this thing, mainly between the teachers, with a lot of people being adamant that the colours they see are the right ones. So how can this be? If colour is really real, how can people look at the same picture and see two vastly different things? Well, the answer's kind of in the question. It's because colour isn't really real. What on earth do I mean by that? Well, colour is a percept, an illusion. It's something that only exists inside our heads. It's an interpretation of light, sure, but there really is nothing objective about it. If I show you a shape, we can all agree that this shape is a square. We can agree this because it has measurable properties that make it a square. 4 sides, equal length, classic square behaviour. Now, tell me the measurable properties that make this square red. And there's the problem. Because there's no way to describe red other than in relation to other colours, there's actually no way to prove the colour you see as red is the same colour I see as red. All we can know for sure is that we have both labelled this colour as red, but we don't know that we're actually seeing the same colour because there are no measurable properties that we can use to compare notes. It only exists in our heads. We can compare wavelengths of light, sure, but not how that translates into the actual perception of colour. Vsauce has already done a great video on this topic, but it goes so much further. And we need to go that bit further to truly understand the dress. Let's go back to our red square, but this time let's put it behind a blue screen. Now what colour is the square? If you're trying to outthink the problem, you might reason the square is no longer red, and you'd be right in that, but you can't deny it does still look red, despite the fact that when I take this blue screen away, you can see it is in fact now purple. This is because wavelength of light doesn't always dictate the colour that we see. No. What your brain is doing here is actually very clever. It's trying to ignore the blue screen to tell you the real colour of the red square underneath. And this is something it does all day, every time light levels around you change. Every time you move inside to outside, different times of day, it tries to keep objects around you as constant as possible, simplifying the world to tell you what is most helpful to see, rather than what is actually there. This doesn't just happen in colour perception, but in other aspects of vision too, making illusions like this possible. And it happens in other senses. We hear what we want to hear just as much as we see what we want to see. The reason the dress appears as different colours to different people is because your brain is trying to tell you the real colour of the dress, discounting all those lights over the top, in the same way as it did for the red square. But the difference this time is that because of how the picture is cropped, your brain has to guess what those lights look like. Does it guess that the light is more yellow, as artificial lighting often is, or more blue, as daylight often is? And depending on how it guesses, depends on which colours you see, with some researchers hypothesising that people who spend more time indoors are more likely to see the dress as blue and black as they discount the yellow, whereas people who spend more time outdoors are more likely to see the dress as white and gold, discounting the blue. There has actually been a lot of research about this dress, with scientists trying to predict which people will see which colours. But we still really don't know. Some scientists have predicted it's a certain pigment in the eye, others have looked at age and gender, others look at where we focus in the image, but we still can't predict who will see what colours. And this is one of the reasons that colour is so maddeningly wonderful. But why stop there? There are other optical illusions which are just as much fun to explore. Take this absolute classic. Keep staring at the cross while I talk to you. The way we see colour, keep staring at the cross, is using 3 types of cells called cones, which are spaced out across our retina, which is the light-sensitive layer at the back of our eye that actually allows us to see, keep staring. There are 3 types of cones which roughly translate to red, green and blue, and when we stare at colours for too long, these cells get tired and can't send signals to the brain anymore, which means when I do this, you see the opposite colours, as the ratio of red to green to blue is skewed in favour of those cones I didn't just tire out. But if colours are an illusion, then why can we see them at all? Well, it's thought that colours have survived the test of evolution by allowing us to forage better and avoid predators. This is also why most animals that are monochromats, meaning they only have one cone and see in shades of grey, tend to be nocturnal, like bats and raccoons. Cones would only be a disadvantage for them as they're actually less sensitive than the other type of cell in our eye, rods, which don't see in colour but are much better at night time. This is why even we tend to see in shades of grey in the dark, and why if you're stargazing you should never look directly at the star you want to see, but instead slightly off to the side, as this will allow you to make better use of those uber-sensitive rods. Most animals, like dogs and cats, are dichromats, meaning they have 2 types of cones and so can see colour, just not as many as the average human. But with that being said, there are also some humans who are dichromats who we label as colourblind. You will note, this does not mean they cannot see colour. Typically, people who are dichromats are missing either the red or the green cone, though blue is possible, just much less common. This makes it much more difficult for them to discriminate between different colours. For example, my dad is colourblind and will often report seeing a reddy, greeny, browny colour and a pinky, purpley blue. This is why colour blindness tests often look something like this. So, people see colour in all sorts of different ways, and not just because of colour blindness, but because of natural variation in our eyes and experiences of the world. A square doesn't stop being a square if you spent more time inside or outside, but it can stop being red with a little bit of science. And that's why colour just isn't really real. That's all the time we have for today, but if you have any questions about the neuroscience we've discussed or any suggestions for future videos, please leave a comment down below. Other than that, it's time for me to go back to the lab and plan what I'm going to do for the next video. But until then, please do let me know of any progress you make in trying to take over the world with science!